This is a workflow that I've done a little bit, or quite a lot of in the past, and I'm going to document it for once. So this is a cooler hatch for a Seadoo Speedster, which is a really sort of like cult following two-stroke and four-stroke jet boat that they made for a really long time. There's some weird stuff with BRP versus like getting hull designs leased from Scarab. I don't really know all the details, but they're fun little boats and they've got a long history. So we've got two hinge holes here. There's some like foam tape that goes around here, and then there's a latch and an over travel tether. This is all fiberglass. It's sort of countersunk. So one of the things I do is using like a lot of the patch functionality in VXModel. We actually go in here and get all this smoothed out, and because this is a hand-worked part from BRP, so get it all smoothed out, get the keyhole deleted, and get the hinge holes deleted. Get it all cleaned up, basically, so we've got a blank slate. And then what we do is these entities have been deleted since my thing crashed, but basically what'll happen is I go in here and create a plane off of this, a cylinder off of this, plane here, and all these cylindrical holes for the hinges, and then we're going to take those into Solidworks and basically start making some tools to resubtract these parts from the hatch so that we can have like nice clean features. This is a decimated STL for use in SolidWorks. It's still 74,000 faces, so it's still a lot, but SolidWorks really chokes on anything else. So what we've done is basically got this keyhole, and it's some off-axis stuff. It's kind of weird. So that plane needs to as a surface cut to trim the cylinder, and then we'll extrude a keyhole for that thing to pass through. We're gonna put fillets on everything. When VX Elements remeshes and when SolidWorks exports an STL, it's pretty particular about having fillets on everything. It doesn't really handle sharp edges well, and yeah. So you want to have a really high poly count export from SolidWorks so that when you do a remesh, it doesn't get upset. So we'll go back here and import a mesh. It's confusing as off screen. And now we've got that STL that we exported in here. See, it's kind of weird. So what we're going to do, since it's all upset, is remesh this. I should have hidden this body so that you could see it. Oh god. Okay, we don't want that. If you try and go and do these booleans without remeshing, it gets pretty upset. I don't know why I autocorrected to 0.3 a minute ago. Usually if you do a really fine remesh, it'll be a little gurgly around the edges. think I'm being penalized for not putting a radius on the top. So I guess it just goes to show that even these need a radius. So we'll just add a fillet here, just so it doesn't get upset. It's been a minute since I have done this workflow, so I'll go back through this too. Key subtract, save, and then you'll get to see in Solidworks the mesh resolution. See, it's been a minute since I've done this, so I guess I forgot that I can't have any sharp edges. That's a neat trick for importing tooling for Boolean operations into VXModel. There we go. That looks so much more happy. So even this is really clean. The facets, they reach from like the top to the bottom to the cylinder. So I've never really looked to see if there's any different export options to get SolidWorks to assign facets in a different strategy than SolidWorks does out of the box, but remeshing will take care of that. And then we've got some other stuff in here. You can go ahead and start doing all that recalculating. Got these hinges we need to reuse. Good, it's just a half. So so it's fixed. Insert some hinges. Just to mate these and not have to be upset. Just gonna be easier to just add some features real quick to mate these, because nothing, it's not worth the time for a lot of things to make sure that they are all clean and whatnot. Everything's square and perpendicular. It's just not worth it. Let's see if this is finished yet. Nope, we're still thinking about it. Maybe 0.2 millimeters is a little too aggressive. It's okay. We'll just keep cleaning this up. So these will get, I need to add some more detail to these hinges. They'll get a little bit more information because we're actually going to be embedding a plate inside this hatch. and then you see where the hinge point is for these. So basically, these are so upset. We must be busy over in VXModel. So basically, these hinges are just fatigued plastic is probably these edges being on too. So in operation, they're literally just injection molded, and they bend like this. They also have this really neat feature, thanks BRP, where they rip off, and this heavy piece of fiberglass flies into the lake. So that's a really neat feature too, which is why we are making these, is because the rapid disassembly feature that yeets these into the lake there's a guy that injection molds these hinges, and I've tried to explain to him that his prices on eBay are... You have real view on or something? No, you don't. Okay, so this is done reassigning the facets, and let's see. Oh, it didn't do that. You can see that the way that it does these now. Maybe I was on something else. That's good enough. I guess I was on something else when I remerged these. I might have actually resampled that. Oops. So anyway, we'll go back. We'll turn off wireframe. And then we will do the Boolean operation. It still works. I'm working on version 12. They just updated it. Subtract. Target. Like all features removed. Tool is to subtract. If you leave those sharp top to bottom features, it will not Boolean properly. But as you can see, we've been able to cleanly reintroduce this without redrawing anything, and the goal is really to, since this is going to be printed anyway, it doesn't really matter if this model's perfect, because it's going to get body shopped if somebody wants this perfect. So the only real goal is to get this good enough to slice and print. And trust me, it looks fine once it's printed. So the next things we've got to add are the hinge holes over here. And I've got these plates. Already designed. They're basically rivet backers, and they keep the thing from pulling through. And I don't know where I put the DXF for that flat. Rivet backer. It's in Speedster cooler lid. We do have an assembly. need both. Oops. All. Did it just try and replace everything in the model? Uncertain. Ah, these are in here. There they are. Frustratingly enough, the hinges aren't exactly drawn right. The holes are actually accurate. It's really annoying that like people can't get the dimensions right on stuff as they're making it. So, whatever. It just makes things fun. So basically, sort of the plan is, let me just hide. Oh, we have the solid body. Need to hide you, buddy. Go away. I don't know, like, half-inch seems pretty beefy. I don't even know if that'll fit inside the shape or not. That's the one thing that does suck about STLs. There's not really a great. I don't think they can be transparent. I'll have to check. I guess we can try it here in a second. Okay, so both of these do fit in this space. I need to look at the grip range on the rivets is what I need to do. There you are. Actually, this is pretty much the extent of the grip range. I know for a fact. It's an 1/8 inch. So we're going to do these at an 1/8 inch. Because that's just about right. Now let's... bring those up. And then we're gonna be kind of sloppy, I guess. Do some direct editing. Lazy. Do an offset surface 0 on these. Whoop. Doing that. Hide the solid body. Get these holes deleted. Delete hole. Yes. Trim the surface. Move face to give us a little bit of clearance down here. We'll extend this surface. Yeah, why not 25 millimeters? Linear surface, yeah. Knit. Solid. Now this is a solid. Do a sketch here. Don't let me copy these. Come on. Yes, we love external references. Extrude. Oh yeah, this is just for the rivet tails. And then again, you know, quick and dirty modeling, because we are not going to be reusing any of this stuff. Basically, this is extra clearance for the rivet tails once they pass through. And then, so what we've got now is, do we have a single solid body? Where are these other solid bodies? Ah, we're done with these guys. Goodbye. Oh, Mr. Bond, I expect you to die. Of course, that's some really tiny fillets to these, so we don't get upset. I guess we just add them to everything. Okay. Oh, that's right, because it's this hinge. We have patterned that. So we're out of this now. STL. And then basically these are going to be subtract tools. So we can slide those rivet backers in. Like so. So basically, those rivet backers will go in there. Probably way too much extra clearance, but yeah. Basically the idea. So then we'll go over here to this guy. Import mesh. Key subtract. Hinge pocket subtract. And there they are. Gonna remesh these so that it doesn't get upset. Actually got the pocket, the tools we just imported selected instead of something else. See, it just auto-corrected this to 0.3 millimeters. I'm not sure what was up. Alright, let us do that. Up. Up. No dice. Let's just go ahead and do these the other way. I think it'd be more useful anyhow. I don't think we're going to need that for the rivet tails. Go set up the fillets. Clear all missing references. Yeah, should still be good. You go away. And you two go away. You go away. So we're going to try this again. File, save as. So I've changed my mind. I want these to be a little bit tighter than that. Because I don't want to have to try and push these backer plates up. It's the body move. Let's try 0.5 millimeter. Got a 1 millimeter nozzle on the printer, so kind of asking for a lot for it to be 0.5 millimeter. Now we probably need the other direction clearance on those holes. So make it even shorter. And it's definitely going to be upset about those fillets not being there. These. Sweet. Now those should be able to like pound in there a little bit and won't be wrong. And we also need to hide this. That's one of the nice things is Solidworks will only export STLs for what is showing. So if you need a selection filter for what you want to export as a tool, you can just hide it. And that's all that will be included. So now we've got the hinge pockets going in 2 different directions. Import, mesh, hinge pocket subtract. I'm getting an off-screen confirmation of units, so I apologize for going off-screen for things. No, wrong. No, you are not wrong. Oh, what is showing up here? Okay, somehow it's... I haven't had to deal with that before. Alright, so boolean now, it's imported the mesh somehow. So you are the target. And this can get kind of confusing. Oh, we didn't remesh. It's probably gonna get upset. Subtract. Maybe it'll work. I don't think it will. Usually gets upset on the subtract with sharp edges. Yeah, it's upset. Let's do... Yeah, sorry, I got a little mixed up here. No. It's annoying. Because for tiny stuff, you really want the mean edge length to be really low, so that you don't lose details in the fillets, because otherwise they'll get pissed and you end up with kind of like gacky geometry that doesn't really boolean or smooth well. Alright, now we're going to boolean this again. We're going to click subtract. I'm going to select last subtract as the target, and now we should be correct. The other thing is I might go away from these altogether. I've done another one of these hatches that uses a stainless steel hinge, and it functions much better. I just need to reposition the stainless steel hinge in line with the hinge axis needs to be in line with the plastic hinge axis. This was a pretty fun one. So this one actually comes with like a drill guide and stuff. So it actually prints in two pieces, and it's labeled so that, because these holes don't exist. So anyway, that's a neat product. People really like this. I haven't had any complaints about it. And I don't have to buy those stupid plastic hinges that I hate. Cool. Subtract, subtract. There we go, look at that. I got pockets. Pockets. So, yeah, there's no, the only other thing we gotta add is for the, there's like an over travel hole right here. Merged again. So I'll sort of show you guys how to do that stuff. The similar normal tool is pretty good at picking stuff. That's good enough. And then we'll do a circle on this guy. And we just created. Why did this like protects this one? We're not going to do. So that's probably hidden. Yeah, it is. Export all entities. I just like endlessly export references, so I just incrementally name them, and then we'll go create a boolean tool for this in Solidworks. And I'll show you that workflow for this, importing these references. So what that looks like is, I'll turn this back on so it's not, we're not acting kind of crazy. Just go to Insert, Browse, All Files. Where is it? Is it here? I've lost it. Late Speedster Hatch. Ref2. Open. You're gonna fix it and sometimes they'll come up with a body locate command. Just sort of ignore that. And then I actually want to print a test of this before I actually commit to it. So this will probably be different because I'm probably going to embed some feature for this as well. So for the time being, we're just going to make the tap size, or the rivet size. Oh, go away. Trying to look at the drill size of this for these. May have not had an opinion. We'll go with 0.14. Oh, we've done this in this way. Dang it. This actually needs to be in a part. Insert. Can I insert a part from an assembly? Maybe you can't. I guess you can't. That's the other one thing. You have to deselect whatever the pre-selected thing is. It'll insert two things. Kind of annoying. Yeah, that's why that dialog is weird. You can click break link to original part. That's always a wise move. Because then you just have to do it here. And it'll get pissed. You don't have to do it there, but just for model stability later it'll... And I know I've just waved my hands at model stability, but if you do... If you're going to save this, even if you're going to leave sketches unconstrained, it's probably best. To do that. Just best practice. Leave merge result off. See, like this one. Oh, or not. This is one of the benefits of saving frequently. It's you can get out of stuff. That one's still there. Really screwing up a lot in this video. Break link to the original part. Rec 2. You can turn off the locate feature with body move copy as well. It'll just save you having to X out of it. Wow, this has taken a really long time. Just add this tether feature because we've done it 3 times now. I think I've waited too long to break the link on this. I think we're just committed to leaving it. Dirty, dirty modeling practices. I filmed a couple of these videos and I really liked how they turned out. Turn off merge result. Because there's nothing to merge with and you'll just get pissed. And then we will add itty bitty fillets to this so that we can remesh it. And this thing's so beefy, we might just let people pull rivets into the plastic because the other hatches for these they don't have a lot of meat. These things are brick shithouse. So going for subtract. And this is going to be our final subtract before we go slice this thing, run a test. I don't even know if this is going to fit on my CR10. I might finally have to buy a bigger printer. Boolean tool in this is so nice. It's a little limited at times, but you can really do some wonky stuff. This is pretty mild compared to some of the other stuff I've done. Yeah, we'll accept that. Sweet. So now we'll clean this up and see how butthurt it gets about all the sharp edges. Pretty butthurt. Didn't remesh this. Really not winning today. Because when you go to do, I mean, I could demonstrate, but when you go to do clean mesh, you'll get really upset about those sharp edges, and you won't get crisp edges at the subtract. When it cleans it up, it will just totally blow the edges of those holes out, and there's not really any great way to fix it. So I think it's because those facets span the edge of through the hole, and it just doesn't really know what to do at the edge, since Solidworks does the facet all the way up the side. There we go. This is probably good for a test print. Clean mesh. See, much less upset. Still upset over here though. It's probably going to blow these edges out. It's really upset about sharp edges. Huh. Actually look okay. Oh, we got some holes. It's kind of typical. And you know, they don't look super great. So it's not like we went and fully reverse engineered this part. But for going on an FDM printer, or even multi-jet fusion parts, it's absolutely good enough. And I mean, you could spend a lot of time resurfacing this. We're working straight with the scan data, so all the wonky geometry that from the stuff being warped either out of the mold or bolted in place, that's all accounted for, and then you get to resubtract nice cylindrical features from things. It's not dynamic, so it is more of a sculpting thing than a drafting thing. Yeah, I'm going to get Prusa Slicer configured for the CR10 because I don't have it yet, and to print this on end, I want to do it with organic support so I don't waste an epic amount of material. So give me a second to dial this in, and I will rejoin. Alright, well, I was barely able to fit this in the CR10 build volume. This is 1 kilogram and 2 days and 4 hours. So the CR10 is fired up downstairs. Yeah, 32 parameters, 30% gyroid infill, and organic supports. This is still a 2-day print. Some of the other cubs I make are closer to 2 kilograms, and they are 50-hour prints. So this is about right. This is a little bit larger. It's probably going to be a pretty expensive part to print. I just really hate molding, so printing is really the way to go. We're going to see what these 1mm supports look like. Pretty excited to see this come off. Well, there's a lot of work left still to do, but here's the original part, and here is the reproduction print off of the printer. So still a lot of work to do on this guy, even though that initial print is done. Took 3 of these, 50-hour print. There's some features down here for hinges. Gotta make some decisions on those. There's a live hinge, a plastic live hinge that came on these stock. It's part of why a bunch of them are in the river, because they do fatigue. And then I was able to locate the locks that go on these. That's cool. From Master also. So I even have a 3D model. And yeah, I'll do like a quick maybe YouTube short once these are done. But you get to see some of the VXModel and scanning workflow that I do to get things cleaned up to make them printable. So this guy ended up only being 1 kilogram of plastic. Probably be a couple, you can kind of see through it. There's gyroid infill on it. But yeah, still not a great way to outsource these large prints like that. So kind of stuck doing them at home. But stay tuned and see what happens next.